In today's video, we will discuss about two sums related to work done. So the first question is, if F is equal to this value, this much of Newton, and D means displacement or distance, this is equals to this much of meter, find the work done. So in previous video, you already got the concept that work done is nothing but it is the W is the dot product of force and displacement. Okay, so here you can see that force is in vector form, that is also in vector form, so we will take the dot product of these two, F and D. Okay, so here we did this one, substitute the value of F, substitute the value of D, then the rule of dot product. What we do, we multiply the coefficient of I with the coefficient of I. So here the coefficient of I is 2 and here it is 1, so 2 into 1 is 2. Coefficient of j is 3, here the coefficient of j is minus 1, so 3 into minus 1 is minus 3, and here the coefficient is minus 1 and here it is 1, so 1 minus 1 is minus 1. So finally we are getting 2 minus 3 minus 1, that means the result is minus 2, and joule is the unit of work done. Okay, then next one, number 2, if force F is equal to this Newton, find the work done within distance 2 meter to 3 meter. So here you can see that this force which is given, this is not a fixed number. You see the force is, it depends on x, so that means it is a variable force. And if you remember, for variable force we have this formula, this one, no, W is equal to integration of f dx within certain limit a to b. I wrote in the previous video a to b, you can write x1 to x2 also. Okay, so since the force is variable and since it is a function of x, we are considering that the force is along x-axis. Okay, now when we are doing the integration, substitute the value of f, the whole value, 5x square plus 2, dx will remain as it is, this one. In previous video, I think in place of dx I wrote dr, but since here f is a function of x, we will write dx. Okay, so dx, then see it was dot product here, f dot dx, but we also know that dot product means it is actually f dx, then what, cos of theta. Okay, that was the formula, dot product a dot b means ab cos theta. So similarly f dot dx means f dx cos theta. What is this theta? Is angle between force and dx. So already I told you that force is along x-axis and dx is always along x-axis only. So what is the angle between them? Both are in x-axis, so angle is 0. So cos 0 will be 1. So that is why this term is not there, we have only f dx. Okay, so since we have only f dx, see the value of f I have substituted and dx I am keeping as it is. This dot product will no more there in existence. Okay, next one, then we can separate this integration. Separately we can write integration 5x square dx once, then again this plus, then 2 to integration dx. Fine, since 2 is a constant, it will come outside the integration. Here also 5 is a constant, so 5 should come out of the integration. Then inside integration what we have, x square dx. So we have the formula, you have used it many times, integration x square dx means it is x cube by 3. Then lower limit is 2, upper limit is 3, plus for this one integration dx means it is x, lower limit 2, upper limit 3. Next what we do, in place of x once we will substitute the upper limit, that is 3, minus again in place of x we will substitute the lower limit, that is 2. So the thing becomes like this, this 3 will remain as it is in here, once it will be 3 cube, then minus 2 cube, this one. Okay, then plus this one, in this x will be replaced by 3 once, upper limit minus 2, so 3 minus 2 means it is 1, so 1 into this 2, it gives us 2 only. Okay, then that is simple calculation, 3 cube is 27 minus 8, 2 cube is 8 by 3 plus 2, this 5 is there, multiplication, then you do the calculation, 19 by 3 5 into 19 is 95 by 3. If you calculate, it is 31.66. It goes on like that. So we can round it off till like 31.67 plus 2. So it gives us 33.67 joule. Okay, thank you.